Hello everyone, and welcome to this next video in this series looking at the Maths IA, the internal assessment. Now today's video we're going to take a bit of a deep dive into criteria A and B, looking at how you should present your work, how you should set it out, and the mathematical communication. Now writing the IA is not really a linear process. You don't sort of tackle criteria A then B, etc. This is something that should be on your mind throughout your writing, and something that you should particularly then go back to when you're finished with the IA, just to polish it all up. There are plenty of marks to be got in these criteria that are really independent of the kind of the mathematical quality of your work. So you really should be able to top these out without too much difficulty. So first off, let's get into criterion A. A is all about presentation. These are going to be lots of things that are standard across your IAs from all your other subjects that you need to get right. Digging into the criteria, we can see there are some quite important words that IB mentioned there. So we can see that we're talking a lot about coherence. We can see we're talking about organization, and we can see we're talking about being concise. Now, lots of people talk about a page limit for the IA. 10 to 12 pages. Sometimes people talk about no more than 20, etc. Those aren't really hard and fast rules. The IA does need to be concise though. You will realize though you're not really being marked on that until you've got up to the 4th mark for A. So I think some people stress a little bit too much about that. Probably better to write too much and then at the end perhaps chop down. I'll come to that in a moment. So first off, coherence, and you can see here they do say a coherent exploration is logically developed, easy to follow, and meets its aim. So first off, you want to think about your aim. Now, this isn't an EE, you don't need to be driven by a research question, but you should have a loose aim. You know, I want to find out what factors affect blah, or how can the migratory patterns of the Atlantic swallow be modeled by this formula, right? Have a question that drives your IA forward. Talk about that in your introduction. Be really clear about your aim, and also have a rationale. Why is it that you want to look into this? Now, you're not really judged on the quality of your rationale. You're just asked to provide one. Okay, so obviously really good rationales can be, you know, this might help the understanding of scientists as they study the species or stuff like that. But sometimes the rationale can just be, you know, it's a real area of interest of mine. I'm interested in studying this at university. Remember, it's not about the quality of that rationale. It's about just having one. So we've got an aim saying what we're going to try and achieve. And we've got a rationale that tells us about why we're doing this. And we've also got a conclusion at the end which refers back to the aim and rationale. So that's what the coherence is, right? You shouldn't have one aim, do some maths, and then conclude about something completely different, right? You shouldn't have, you know, the rationale right at the end of page 7. It should be aim, rationale in the introduction at the beginning, main body of the essay, and then a conclusion that relates back to them. It's that coherence. As I said last time, get a peer to read this through. If it scans properly, even if they can't understand the maths, if it scans properly and they can read it, then you know you've got a clear and coherent IA. Then organization. This kind of, again, it's a bit of overlap here with it, including the introduction, describes the aim and has a conclusion. And this really then is about how you organize all the writing and the maths around each other. So relevant graphs, tables, diagrams should accompany the work in the appropriate place and not be attached as appendices. Now this is one sometimes students get wrong. If I'm going to show you a graph of, I don't know, temperatures in Beijing over January and February, right? I'm not just going to drop that in my IA with no explanation. I've got to have something above it which says, you know, I will now try and show blah, blah, blah. And remember, this all has to link back to that aim and that rationale. Why are you showing me this graph? How does it link to the aim? So tell me what you're about to do. Show me the maths and then comment upon it, right? Think about the reading order. You want the reader to understand why they're about to see the graph, then look at the graph and then read your commentary on the graph. So it should flow nicely. The appendices are really useful if you've got lots of repetition. So let's say you're calculating, you know, the Gini coefficient for a country, for example. You might have 30 countries in your study. You're probably going to automate a lot of this calculation. You don't want to include it all, but you do want to show the marker that you know how it's calculated, and perhaps give an example of the calculation. So your first one you might include and really explain every step. Again, that's about communication, presentation, explaining the steps in the calculation, showing how it all works, showing off your math skill, and then say, you know, the calculations for the remaining 29 countries are included in Appendix A. So it's a good way to show that you have done the maths, that it's there and it's a proper, you've actually done it. But you're not going to flab out the essay and make it 50 pages long by having all this repetitive calculation. You will be penalised for repetitive calculation. So drop it in the appendix, but bear in mind, nothing in the appendix is required to be read. So anything that is only there for its own sake, so like repeated calculations, it's good to include them just in case anyone was curious, or you know, they might have a question about the validity of your work. But you don't need anyone to read those. After the first one where you've really explained it, they're not adding to the essay. So get them in the appendix, but bear in mind no one has to read them. So as I've said there, you can also use those for large data sets and additional graphs, diagrams and tables. I'd be really cautious about graphs, particularly because I think often if you're drawing a graph, you want it to show something, and if you want it to be seen, it should probably go in the main body. So that's kind of what they mean there by well organized. And again, think about, does it read well? That's going to do a lot of your lifting here. Finally, concise explanations, not show relevant or unnecessary repetitive calculations, blah, blah. So that is just about kind of doing too much of the same stuff, repeating yourself, or just having too much bloat, I guess, in the essay. So this is when you've written the whole thing, you can go back and think, okay, could I cut that? Does it, if I remove this, does that ruin the flow of this section? What if no one reads it? So ask those questions to yourself, and if you're happy, you can then pop those in the appendix. Again, it says use of technology is not required but encouraged where appropriate. And analytical approaches rather than technological ones do not mean lack of conciseness, should not be punished, but that doesn't mean the repetitive calculations are condoned. So if you want to take an analytical approach to perhaps a least squares regression, that's great. Again, it allows you to show your math skill, but make sure it doesn't get too bloated. Perhaps you would do the first one by hand and then the rest can be done by technology. Computers are really useful, so I would be using them here, but it is up to you. So that's it for Criterion A. This can be thought of as how well you write and how well the IA flows. Criterion B, this one is your mathematical communication. Now, there is a bit of an overlap here between A and B, because if you don't communicate your maths well, you've not communicated well overall. But as teachers, we try and not double penalise. So I've often marked IAs where I've said, oh, I've taken a mark off in section B and not in section A, and this is the reason. So you can do a lot of justifying here as a marker to try and avoid that crossover. So we can again have a look. There are again some key words that they drop in here. We're talking about appropriate communication. We're talking about it being relevant and consistent. Those seem to be the key things here. Now, again, these are defined below, but mathematical language is really important. Getting the right symbols, shorthand, etc., because these stick out like a sore thumb. So, you know, one of the kind of the big culprits is, particularly when you're doing lots of stuff in Excel or with technology, people start writing things like 1.2 E6 because that's the computer or calculator way of writing standard index form. That's going to get you penalized straight away, and even sometimes even just one or two little slips like this can cost you a mark. So be really cautious here. You've got to use all the proper expected notation. You know, other examples we can see are things like people writing integrals without the dx. You know, these are little slips, and they're the kind of thing that you're going to forgive yourself in your classwork, but in your IA, everything needs to be really on point here. Another big mistake we see a lot is key terms and variables not being defined. You've got this lovely big formula, you know, that describes something, perhaps it's arc length or it's Gini coefficient, whatever it is, but if you don't clearly define every variable in that formula, it doesn't make sense to the reader. You know, nothing is more frustrating than just a there's a C in there. What does it mean? What does it stand for? Are we guessing? So before you put in any formula like that, it's even really nice to start having it in like a little table, really clearly defining every variable. If I'm reading through an IA and I ever get to a point where I go, what does that mean? Then that's almost certainly going to cost you a mark here. So be really careful about that. Now, using multiple forms of mathematical representation, the key bit here is this where appropriate. We do often see with students just sort of shoehorning things into an IA just because. You know, here's my data on a scatter plot, and here it is again in a box and whisker diagram, and here it is as a stem and leaf, and you think, okay, but why? Right? So the appropriate here and relevance as well, everything should be given a reason. Why are you now showing me it as a box and whisker? Is that because that's a nicer form for you to identify outliers in? Great. Tell me that, show me the outliers, write a little comment underneath about them, right? Don't just do maths for its own sake. Think about what does it say to your aim? How does it speak to your aim? We've got examples of level 1 can include graphs not being labeled, consistent use of computer notation, etc. So the labeling thing is also really important. Yes, you might think if you write a graph showing GDP of countries versus time, that it's obvious what your axes are, and I'd agree, but you still need to label them, right? And again, 1 or 2 slips here can cost you quite dearly. I think the key there is sort of relevant, appropriate. So that's all about justifying each piece of maths that you do. Why are you doing it? How does it talk to your aim? And then the consistency, really that is just about no slips. So we're really going to want to see perfect mathematical communication for a 4 here. This can tend to be a criterion that's negatively marked. You know, if I'm reading through it, all the maths make sense, everything's great, I'm going to start at a 4 and then perhaps say, okay, well, how many mistakes am I going to allow before I knock that to a 3? How many mistakes am I going to allow before that gets knocked down? Now, again, that might not be the spirit of what IB is intending, but I think in practice, sometimes that's how this one ends up getting assessed. So what we're going to do now is just have a look at a couple of examples of IAs that these have been put out by IB, and these score well in each of these criteria, but we can see some slight flaws that perhaps have cost them. So first off, this one is looking at graphing pharmacokinetic profiles, so something, you know, medicine-y, I guess. We can look through here. There's some annotations been provided all about. We're looking specifically for A's and B's today. So A, we've got a bit of an intro and rationale here. You know, this prompted me to think about how doctors graph these medications. It's a great rationale. This person's thinking about a career in medicine. We can go through. We've got a lovely graph here. Now, this one does look to me like it's been just copied and pasted from a source, but it does look again like we've got a reference for that here. So no problem doing that. It's not necessarily going to kind of get you that many marks, but that's not really the aim of this graph here. This is lovely. You can see that the commonly abbreviated variables in this piece of work are all clearly defined here. That's really, really important. This is scoring them well in Criterion B. We have got a little bit more. I think this is really just describing what's seen in the graph. And again, look, we've got a title. We have axis labels, we have clear axes, and a key to help read this graph properly. Really good, really strong graph, that one. But again, I think that is, again, a citation here, so that's not their own graph. We then get into some of their own graphs, and the same thing seems to be true. This label is a little bit clumsy. That's perhaps not great formatting, but I think either been overlooked or forgiven. So this is all looking pretty good for B. Again, this is a really nicely performed graph. We can see the different sections under it. Still that same labeling error, but you know, it is labeled. Equations here are laid out nicely. The general pattern you want to go for is justified text, so left justified your text, and then all your equations centrally justified, so that they stand out nicely and we can read them. This is all good, lovely graph, no harm with a splash of color, helps me read this nicely. We've got areas given in a table. Tables are a really strong way of organizing data. This thing is concluded. There's some good stuff here. You know, these equations again are central, and I can read them really clearly. We've used the correct form of inequality here. You could use interval notation. IB is happy with either. The student's gone with those. We then look through, there's some more nice equations here, no big problems. This is all starting to look really, really good. And obviously I'm not allowing you time to read this here, but the flow of this is really good. So before each graph, you know, there's a discussion about what this is going to contribute to the aim and how it's going to be contribute, and then we've got a bit of a mini conclusion about the graph here. That's a nice sort of pattern to go through. Unfortunately, this student does just let themselves down a little bit with some of this maths. Now, again, talked about interval notation earlier. There's some nice stuff in here using that. There are a couple of mistakes that creep in here. We've got a problem with the period of this graph here, and I think a 1 over 0.5. And then we also see a mistake down here. There's that missing dx. So this IA is really, really good and scores top marks in A, but a few of those errors are just enough to cost them 1 point in Criterion B here, unfortunately. So that's that one, but overall a wonderful IA. We can see a slightly different thing here. This I think this one is getting top marks in B, but just losing out in A. So scrolling through, we can see again, you know, this is even nicely laid out. Maybe we've got a nice title, we've got subtitles, introduction. We can see a bit of that they've labeled personal engagement here, but we've got a clear aim. I plan to focus on understanding the SIR model and applying it to a real life epidemic that occurred in the past. You know, your aim doesn't need to be massive and huge, just something simple like that. And there's a rationale included there as well. We've got variables really carefully defined, both in terms of a shorthand and a derivative form. Key terms are being explained here. That only helps in Criterion A. Unfortunately, there's a few little errors here, not that well defined in this section. We've then got some, again, more personal engagement being pointed out there. This is the kind of thing that really is going to end up costing you. And again, sometimes the marker might penalise this in A, sometimes in B. We multiply the initial values by 1 over n. What's n? It's not been mentioned. And so that really, anything like that that jars you and takes you out of the flow of the essay is potentially going to be penalised in Criterion A. We could also argue that the definition of variables comes under Criterion B. What we're going to try and avoid is double penalising here. So hopefully they've just lost, well, they have just lost 1 mark. We'd like a little bit more explanation here. So there's, I think, something I'm always conscious of when I'm looking at students' work is, have they just, you know, cribbed this off the internet or seen it in someone's work and, oh, this line becomes this line as if by magic. Whenever there's a lot of steps being done, it would be nice to just see a little bit of explanation, or maybe the steps broken down. If your purpose is to understand the maths, is to understand the process of SIR modelling, you really want to be delving into every little bit and how it's all derived and explain that, because nothing shows your understanding like explanation. And again, this comes into Criterion D later, the maths, Criterion E even. You need to show understanding, and showing understanding is often about explaining. You know, lovely graph here. We've got some color coding again. Axes are labeled. It's got a title consistent with their referencing style, and the markers labeled here. You can see the graph is defined clearly by the data in the appendix. A long table here would detract from communication. So obviously, really clear comment there. You know, a massive 2-page data table is not really adding, particularly given the graph. So mention that the data is in the appendix, just show the graph. Good plan. And yeah, so more good stuff here. You know, again, we've got everything's defined carefully. We've got nice centrally justified equations. We've got this looks like Euler's method numerical differentiation, I think, for a differential equation, laid out in a table really nicely. But you can see here that, you know, using a bit of ellipsis to shorten that. More nice graphs, all given citations and so on. A little bit too wordy here, so that's something else we can fall into in terms of being concise. You know, if you're spending a whole page to say something that you could say in 3 sentences, you're maybe going to lose that concise mark. So this student overall seems to have done a really good job, particularly in Criterion B, but it's just going to drop that mark in Criterion A, I think. So that's the sort of stuff you want to be looking out for. Like I said, read through this before your IA, have it in mind while you're writing, and then at the end, go back and just really be picky. Have that fine-tooth comb, go through everything. Is that variable correctly defined? What does this mean? Why is there an n there? Have I missed a dx? Those things can cost you a mark, and this is marked out of 20. 1 mark is 5%, right? So be careful, go through this again at the end of your IA process, and good luck. Thanks for watching.